Hi everybody, we're going to talk about exponents and powers and bases today. Here's one really good question to start you off. Here's two options. If I were to provide you with these two options, which one would you choose? So option A, you're to receive $1,000 per day for 31 days. So would you take that one, or if you want to choose option B, you would take 1 penny on the first day, but then that penny doubles for the second day, and then doubles on the third day, etc., etc. So after 31 days, which one do you think is worth more, or which option would you choose? So I'll let you think about it and try to see if you can calculate something out of it and maybe provide a good reasoning for your option. So after a couple seconds or a minute or however long you took, you should have chosen option B. Because if you look at option A, right here, since you're making $1,000 per day and you have 31 days to do so, basically it's just 1,000 times 31 days, which gives you $31,000. But if you look at option B, this is where we get into using powers or exponents and also exponential form. Because in exponential form, everything, if you have exponent 2, it doubles. So to give you an idea, say day 1 we started off with a penny, and it doubles to second 2 pennies, 4, 8, and then you can see that it goes on, and this pattern is what you call exponential growth because it doubles after every day. And you can see that even though after 15 days, it's still not that much compared to your $31,000. But as the numbers get bigger, the growth gets a lot larger. So even on the 19th day, you have 2,600 already. And once it gets into here, you have $20,971. And next double would be double that, double, double, double. And you can see that, oh, I'm jumping ahead. You can see that finally, after 31 days, just from starting with 1 penny, you have $10 million by starting 1 penny. So imagine if there's a way of really doubling our penny in just 31 days. And if you can, man, you'll be pretty rich. So this is why we use powers and exponents, because we can actually use that to see the growth or to showcase numbers that are really, really big or really, really small. And going back to the previous example, you can see that we started off with, say, a number like 2, but after every time it doubles. So instead of writing it like 2 times 2 times 2 times 2 times 2 times 2, there is a shorter way to doing this, and that is what we call your powers and exponents. So let me just switch to my pen here, and when you have a power exponent, there's a couple of things you need to know. So you can see that we have 3 forms right here. One is the exponential form, and I think the E is a little bit cut off, and then you have the expanded form and standard form. So going back to the previous example, say we have 2 times 2 times 2 times 2. This is the expanded form because we wrote all the numbers out. So 2 times 2 times 2 times 2. If we were to write an exponential form, we're going to keep the number that we multiply it by. So that's my base. And an exponent is going to be like a little superscript that appears in the top right corner. And that's the number of times that this base was multiplied by itself. So since there are 1, 2, 3, 4, not 4 times 2, but there are 4 copies of the 2, we're going to write 4. And the standard form basically is your answer. So what is the answer for 2 to the power of 4, or 2 to the exponent of 4? Well, that's 2 times 2, which is 4, times 2 is 8, times another 2 is 16. So that's your standard form. So to give you another example, let's say 5 to the power of 3. Okay, so to write this expanded form, this again is your base. So this is going to be your 5 times, how many times does it multiply by itself? 5 times 5 times 5. So this is going to be 5 times 5 is 25, times another 5 is 125. A really good example I use is, since a lot of people, one very common mistake is that when they see something like 5 to the power of 3, a lot of people make the mistake of saying it's 5 times 3, but this is wrong because that's not multiplying. This is the exponent. So a good visual that I try to use is that I try to use a photocopy machine. So have you ever seen a photocopy machine or a scanner? Here's the lid. I don't know if this is really drawing drawing a photocopy justice, but on the side there's a panel, and basically the base, this 5, I would think that I would just kind of imagine that's the thing that you're trying to photocopy. So this is your 5. So this is going to be your sort of your photocopy, and then, well, in order to use a photocopy machine, you need to tell the machine how many copies. So you're going to enter it here. So what you enter, the number of copies, is your exponent. And once you push the start button, all this stuff comes out from this tray. And if you push 3, you're going to have 3 copies of the 5. So this makes it, I'm just going to finish this off. So you're going to have 5 times 5 times 5. Okay, so another example, I guess, if we were to say 10 to the power of 6, well, 10 is your base, so that's what you're going to photocopy, and 6 is your exponent. That's the number of copies that you'll have. Your base will always be the number of copies, or that's the what you're photocopying. So if I have a letter A to the power of 5, that is, A itself is going to be what you're photocopying, and 5 is going to be how many copies. So this will be A times A times A times A times A. Okay, so that's how you would want to think about exponents.